So now we're going to get into drawing Lewis dot structures. So the first thing we want to look at is the octet rule. So I kind of mentioned this already, but atoms will gain, lose, or share electrons to get to the 8 valence electrons. So all the noble gases, well, not all the noble gases, but most of the noble gases have 8 valence electrons, and that makes them very stable. And so everybody else wants to have that same stability. So that's the goal, to get to these 8 valence electrons. The octet rule only really works for the main group elements, which is all the group A elements, but the transition metals don't have that same rule. They're more concerned about their D group and their F group, so we don't really do the octet rule for transition metals. So the Lewis dot structure, again, we draw the symbol and we put their valence electron as a dot next to the symbol. But when the electrons are being shared in a molecule, so we have hydrogen here, we have 2 hydrogen, they're both sharing one molecule, and it forms a bond. So the line between the hydrogens represents one bond. So a line always represents 2 electrons. So here hydrogen does not have an octet. Both of the hydrogens only have 2, and that represents what we call a duet. So hydrogen is happy with a duet. It does not want to have an octet. So there are exceptions to the octet rule. Okay, here we have hydrogen and fluorine coming together. So hydrogen has 1 valence, fluorine has 7. So they both share an electron between the 2. So we see the line between H and F. And again, that represents 2 electrons and a single bond. But then we also have dots around fluorine. And the fluorine dots are called lone pairs. So anytime you have dots on an atom like that, we're going to call them lone pairs. So fluorine does have an octet. So the line represents 2, and then we have 3 lone pairs, which are 6 electrons. So altogether, fluorine has 8 valence electrons around it, and hydrogen only has its duet. Now sometimes a single bond is not enough, and so we need a double bond. So oxygen, O2, in order for them to form a molecule, they have to share 4 electrons between the 2 of them. So that creates a double bond. So still, when we have one line, it represents 2 electrons. So here we have 2 lines, so that means a total of 4 electrons are being shared between the oxygens. But they both have an octet now that they've shared 4 electrons. They both have an octet. Okay, here's some more examples with double bonds, and we're going to get into the rules and how we know a molecule has a double bond or maybe even needs a triple bond. So for nitrogen, they have to share 6 electrons between the 2 of them to get them both to an octet. So each line still represents 2 electrons. Okay, so we are going to go through the rules and how to draw Lewis dot structure, and as we do this, we're going to draw PCl3. Okay. So the first rule says make a skeletal arrangement of the atoms. And then the second rule says determine the total number of valence electrons. Okay, so first up we're going to decide what the central atom is. So usually if you have one element that only has one atom, that's going to be your central atom. So we have 3 chlorine. Those 3 chlorines are going to go around phosphorus. But if you're unsure what the central atom is going to be, then it's always the one with the lower electronegativity. Okay? So you can always look at that and figure out what your central atom is. Next, we're going to figure out the total number of valence electrons. So phosphorus is in group 5, so that means it has 5 valence. Chlorine's in group 7. But we have 3, so we have a total of 26 valence electrons that we need to represent in our structure here. so the first thing I do is I put a line between all of the atoms just to connect them. And then we're going to put lone pairs around the outside atoms. Okay, so I'm going to draw a line between phosphorus and chlorine. So far we've used 2, 4, 6 electrons with just putting those single bonds in. Now we're going to put lone pairs around the outside atoms to give it an octet. So this chlorine already has 2. Now we're going to put 4, 6, and 8. Okay, we're going to do the same thing for the other 2 chlorines. Okay, so now all the chlorines have an octet. And we need to figure out how many electrons we've used so far. So we've used 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So we've used 24 valence electrons, but I have 26 total. So anytime I get done putting valence electrons around the outside atoms and I have any electrons left over, they always go as a lone pair on the central atom. So a lot of times people are tempted here to throw in a double bond or something like that. Okay, don't do that. I'm going to show you how you know when you need a double bond. So if you ever have electrons left over after you've given all the outside atoms an octet, you just put them on the central atom. Okay, so I want to do one more example to show you how you know you need a double bond or maybe a triple bond. So we're going to do rule number 5 here. Okay, we're going to draw CO2. So again, we only have 1 carbon and 2 oxygens, so that tells us carbon is going to be in the middle, oxygen's on the outside. So we've drawn our skeletal arrangement. Now we need to know how many valence. So carbon has 4 valence because it's in group 4. Oxygen has 6 because it's in group 6, and we have 2 of them. So we have a total of 16 valence electrons. So we start by putting in our single bonds, and then we're going to put in our lone pairs around the oxygens. Okay, so now both of the oxygens have an octet. So let's count and see how many electrons we've used. 2, 4, 6, 8, 10, 12, 14, 16. Okay, we've used all 16 electrons. So both of the oxygens have an octet, but carbon does not. Okay, carbon only has 4 electrons, and we want it to get him, to have 8. So here's where we make a double bond. We've run out of electrons, and our central atom does not have an octet. So what we're going to do is we're going to take a lone pair off one of the oxygens, and we're going to share it with carbon. It doesn't matter what lone pair you take. I'm just going to take this bottom one here, and then I'm going to share it with carbon. So now oxygen still has an octet, but now that gets carbon to 6 electrons. So we're not quite to an octet, so we're going to have to do the same thing on the other side. So again, it doesn't matter which lone pair you take, and then we just share it with the other carbon. So now carbon has 8 electrons. Both oxygens still have 8, and we are done.